Okay, so for this example, we want to find the limit as x approaches 1 of x squared minus 1 divided by the square root of x plus 3 minus 2. And the first thing you'll notice here is if you substitute in 1 into this function, you get the form 0 over 0, which is indeterminate, so we know we have to do some algebraic manipulation. Now, since you see the square root, this is crying out for us to use a rationalization process. So the first thing we're going to do is going to copy this over again. And now we're going to rationalize the denominator by multiplying by its conjugate, the square root of x plus 3 plus a 2. And of course, we have to do whatever we do down below, up above, to keep this equal to the original. All right, so the next thing we're going to do is selectively multiply this out. We do not want to simply multiply everything out and have a big mess in our hands. Rather, we want to keep some stuff FOILed out and some stuff factored. So kind of tricky, but you'll kind of notice when you do more examples of these that we have to be kind of careful. One other thing, that x squared minus 1, we're going to factor it as x plus 1, x minus 1, because we know we're going to be doing some simplification very soon. So that again, square root of x plus 3 plus 2. And now we're going to selectively multiply out the bottom. So if we multiply the square root of x plus 3 times another x plus 3, that just makes a x plus 3. And then we have plus 2 square root x plus 3 minus 2 square root x plus 3, and then minus a 4. And you'll notice that the middle terms always cancel. And we also notice that we've got an x plus 3 and a minus 4. We could combine that together to make simply x minus 1. So this is equal to the limit as x approaches 1. Upstairs, we've got x plus 1. We've got x minus 1. We've got the square root of x plus 3 plus a 2. And then down below, we have just x minus 1. Now you'll notice we can cancel out those x minus 1s in the numerator and denominator. And we're left with a limit problem that we can find by direct evaluation. So again, we've got x plus 1 times the square root of x plus 3 plus 2. By direct substitution, that's 1 plus 1 times the square root of 1 plus 3 plus a 2. Simplifies down to 2 times the square root of 4 plus 2, and that's going to make 2 times 4, which is simply 8. So we've shown that by rationalizing our denominator, we can find this limit, and we can go ahead and get rid of that removable discontinuity.